I talked a little bit about this in the last lesson. Inverse variation graphs are called rational functions. And this is the most basic one, y equals 1 over x. So this is just like the graph that we did in 11.1, where it makes this weird shape that looks like two graphs, but it's really one. Since a rational function deals with fractions, the denominator can never be 0. And we experienced that when we graphed earlier. Therefore, any value that makes the denominator 0 is called an excluded value. So let's just take it one piece at a time, and let's find out what the excluded value is. So if you have this function and you want to figure out what are the excluded values, you say, well, the excluded values are anything that would make this equal to 0. So if x plus 5 equals 0, then negative 5 would make this, would not be able to be graphed. Speaking of graph, let's try one. I've set up a table for you so you know what numbers I want you to plug in. So can you pause the video, plug in the numbers, and then when you're ready to continue, play, because I want you to make sure that your numbers match mine. All right, hopefully your numbers match mine, and let's graph it. Oh, whoops, that's supposed to be negative. I'm going to put a dashed line down x equals 1 because I want to make sure that I don't touch that line, because if you see from the table, 1, anytime the x value is 1, it makes it undefined. So the first half of my graph looks like this. So now let's graph the other side. And I have to make sure that I don't touch that blue line. Label it y equals 1 over x minus 1. What value is excluded from the graph? Well, that's the value where x equals 1. The graph seems to approach the line but never touch. The name for that, and the name for this blue line, is called an asymptote. So please spell it correctly. Asymptote is the name of a line that a graph seems to approach but never touch. We had some of these when we did exponentials, and I didn't call it asymptote, but remember, it kind of approached the axis but never quite crossed over it or touched it. You can figure out what the asymptotes are without having to make a table. You use this idea where it says that if this is the general formula for a rational function, x equals h is the vertical asymptote, and the horizontal asymptote is y equals k. And you see in the equation, there's the h and there's the k. So let's just pick out the pieces. Identify the asymptotes of the graph, then describe the domain and range. So the vertical asymptote is where x equals whatever number is in the h spot. So since it says x minus h, and this says x minus 2, that must mean that the vertical asymptote is where x equals 2. The horizontal asymptote is where y equals k. And so it says plus k here, and it says minus 4 here. So that means that the horizontal asymptote is where y equals negative 4. So the graph will approach the line x equals 2, but never quite touch it, as well as approach the line y equals -4 but never quite touch it. Now in a rational function, since there are two sides to a rational function, your domain is typically all real numbers, except for whatever value is the asymptote. So this means that the domain is all real numbers except for x equals to 2. So I'm saying all real numbers except x cannot be equal to 2. That's what this says. The horizontal asymptote is the range, and that tells us that it's all real numbers, but y cannot be equal to -4. So every number is going to work in the domain except for 2, and every number is a potential range value except for -4. All right, let's check out example 3. I've given you a table. Can you please pause the video, plug in the values, and then when you're ready, play, and I'll continue with you. All right, when you're ready, graph the values. -2 is an asymptote, so I'm just going to make my dashed line going down it, so I know I'm not allowed to touch that line. And now I'll connect. And now I go to the other side. And same thing here, I can't touch that asymptote. You want to be careful because according to the equation, you also have an asymptote at y equals 3. So you want to make sure that you don't touch the line y equals 3. See, I came really close. So don't touch that line. This is y equals 1 over x plus 2 plus 3. So that's the first half. We graph the function. Now we have to compare it to the graph of y equals 1 over x. So I'm going to make me a quick little table for y equals 1 over x. This one. So if x, so I'll do -3, -2, -1, 0, 1, 2, 3. So that gives me -1/3. This is -1/2. That's -1. That's undefined. 1, 1/2, 1/3. When you're ready, let's graph. And I've got an asymptote going down here. And that's what that side looks like. We have to compare it, so let's talk about how it shifted. And one of the things that you can use to understand the shift, I know there's a lot going on in this picture, is to look at how the asymptotes moved. So if you compare like the epicenter of the asymptotes, the intersection of those asymptotes and the intersection of these asymptotes, then it's easy to see, relatively easy to say that it went up 3, left 2, from y equals 1 over x. All right, so example 4, I'm going to show you in class how to do these graphs in a graphing calculator. So if you have any other questions, write them down and I'll see you then.